Hello students, welcome back. Today we'll continue with exercise 2. In our last video lecture we had completed till question number 6 of exercise 2 of chapter number 2, that is relations and function. Today we'll start with question number 7 and complete this exercise as well as this chapter. So let's start. Question number 7. Let f, g, r to r. So see here two functions are given, f and g. We define respectively by fx equal to x plus 1. Okay, the function fx is equal to x plus 1 and gx is equal to 2x minus 3. Okay, you have to find out f plus g, f minus g, and f into g. Okay, so first, let me explain you about the arithmetic of this function. Okay, now see, when you are writing f plus g of x, then this will be equal to f of x plus g of x. Clear? And the value of x, that will be the intersection of domain of f and domain of g. Clear? You only can take that value of x. Similarly, if it is f minus gx, then it will be fx minus gx. If it is f into gx, then this will be equal to f of x into g of x. And if it is f by gx, then this will be equal to fx upon gx, but gx must not be equal to 0. Remember this, gx must not be equal to 0. Clear? And see, if the function is defined in this way, f a to b, g c to d, right? Then the domain, in all these cases, the domain will be equal to a intersection c. Clear? Means the value of x, you can only take it if it belongs to a and it belongs to c. So the domain of this function will be a intersection c. There is one more thing here. Okay, here one more thing. Here you cannot take the value of x such that g of x is equal to 0. Means you have to subtract that. Means a intersection b minus x such that g of x is equal to 0. Whereas in the first three cases like addition, subtraction and multiplication, you can take the value of x that belongs to a intersection. See, that means domain of this and domain of this. Clear? Now see, here in this case it is given r to r to r. That means domain of f is also r, domain of g is also r. So r intersection r, that will be r. So all for all this mathematical operation of the function, the domain will be r. Okay. So now let's say first f plus g of x. This will be equal to fx plus gx. So what is fx? X plus 1 plus 2x minus 3. Right? X plus 1 plus 2x minus 3. So x plus 2x, 3x. 1 plus minus 1 minus 3, it will be minus 2. Clear? So this is f plus g x. Okay. Next, f minus gx. F minus g. We have to find out this function. This will be equal to fx minus gx. So what is fx? X plus 1 minus 2x minus 3. So x minus 2x. It will be minus x. 1 minus minus 3. So 1 plus 3. It will be equal to 4. So this will be equal to 4 minus x. This is f minus gx. And the third one, that is f by g. This, this will be equal to f of x upon g of x. So this will be equal to, what is f of x? X plus 1 upon 2x minus 3. This is f by g of x. Clear? So this is question number 7. In addition, we just had to do f plus gx, fx plus gx, subtraction fx minus gx, and a division fx upon gx. Clear? And remember, in this, we cannot take the value of x as 3 by 2. Remember, this is, it's actually the question is finished here, but here you have to understand that here the value of x cannot be taken 3 by 2, because if you take 3 by 2, then 2 into 3 by 2 minus 3, 2 gets cancelled, 3 minus 3 will be equal to 0, right? So this becomes undefined. Yeah. Okay, so this was about question number 7. So note down question number 7. Now let's move to the next, that is question number 8. Question number 8. Let f, it is given ordered pair 1 1 2 3 0 minus 1 minus 1 minus 3 be a function from z to z defined by fx is equal to ax plus b. So let me write it down here. F of x, that is equal to ax plus b. For some integer a and b, and you have to determine a b. Clear? Now see what we had studied. If I am taking this as x, then this will be fx. Right? So f of 1 equal to 1. See, f of 1 is equal to 1. F of 2 is equal to 3. F of 2 is equal to 3. F of 0, that is equal to minus 1. F of 0, that is equal to minus 1. Remember this way, when an ordered pair is given like this way, that means f of x is equal to y. Clear? In a function, if it is such type of ordered pair is given, that fx is equal to y. Okay. So now we can also take f of minus 1 equal to minus 3. We will take it if we will require. Now what is the function given fx equal to ax plus b? So here it is f of 1. So a, see, fx is equal to ax plus b. So instead of x, I would put 1. A of 1 plus b equal to 1. That means a plus b is equal to 1. Clear? Here it is given f of 2 equal to 3. That means again we will use the same a of, instead of x I will write down 2 plus b equal to 3. That means 2a plus b equal to 3. So from this elimination we can find it out, right? So we can use elimination. But here it is f of 0. This will be easier for this. See here. A of 0 plus b equal to minus 1. So a into 0 is 0, right? Actually, it's not a of 0, a into 0. So b is equal to minus 1. I got the value of b, right? I will put this in this equation. So a minus 1 equal to 1. That implies a is equal to 2. I also got the value of A. So the value of B equal to minus 1 and the value of A is equal to minus 2. So this was about question number 8. We just use the function fx equal to ax plus b and we found out the value of A and B. Clear? Just note down question number 8. Now let's move to the next, that is question number 9. Question number 9. Let R be a relation from n to n defined by R equal to AB, ordered pair AB, such that AB belongs to n and A is equal to B square. Are the following true? Okay, that is the question. First, AA belongs to R for all A belonging to N. Okay, so let's solve the first one. Okay, the question is do AA belongs to R for all N belonging to N? So if I take, let's take A is equal to 2. Okay, then 2 is equal to 2 square. Is it true? No, this is false. Now see, as it is not satisfying this equation, right? That means 2, 2 will not belong to R, right? See here relation R means A equal to B square. So if it is satisfying the equation like A is equal to B square, then only that will be belonging to R. So A is equal to 2. So 2 to do it belong? No, right? So first question, no, this is false. So I will write down here no for the first one. Now let's take for the second one. AB belongs to R implies BA belongs to R. Means this you have to take such an example which belongs to R, right? So let's take 1 equal to or let us take AB belongs to R. Okay, let without taking example just AB belongs to R. So what does this mean? A is equal to B square. Clear? A is equal to B square. So do it implies that B will be equal to A square? Of course not, right? This will not be equal to 2 every time. So this, but therefore this implies that B is not equal to A square, right? A is equal to B square, that implies B is not equal to A square. Just take example, if I take 2, 4, 2, right? Now we know that 4, 2, that means 2, 4 is equal to 2 square. That means 4, 2 belongs to R, right? But 2 is not equal to 4 square, right? That means 2, 4 does not belongs to R. 2, 4 does not belongs to R, right? So this implies that BA does not belongs to R. So what is the question? That if AB belongs to R, that must imply BA also must belongs to R. Means if A is equal to B square, then it must satisfy that B is also equal to A square. Clear? So second, it is also no. It is not true. Clear? Now let's select the third one. Okay. We will take example AB belongs to R, BC belongs to R. Means this is satisfying. Here see these are common. Clear? Then AC must belongs to R. Clear? The question is AC must belongs to R. So if I take 16 4. Now we know that A means 16 is equal to 4 square. So it is satisfying this equation? Yes. So this is belonging to R. Clear? Now 4 2 we had taken this, that 4 is equal to 2 square, A is equal to B square. This is also satisfying. So this also belongs to R. Clear? So now it's A C. B is same here. 4 4 same. So what will you say about 16 2? 16 so can I write it down that 16 is equal to 2 square? No, 16 is not equal to 2 square. That means this does not belongs to R. Here, so what does this mean? This means that it is also not satisfying third. So here also I will say no. Here, see, this type of relations you will learn in standard 12. Reflexive, symmetric, and transitive. If it is satisfying this first, then it would be reflexive. If it is satisfying second, then it would be symmetric. If it is satisfying third, be transitive. Okay, but at present you just have to prove this. Clear? So this was about question number 9. Just note it down. Okay, now let's move to the next, that is question number 10. Question number 10. Let A, the set A is given 1 2 3 4. B, let me write it down here, set A, that is equal to 1 2 3. Set B, that is equal to 1 5 9 11 15 16. And F is equal to 1 5 2 9 3 1 4 5 to 11. Right now, see, two questions are, the first one, is F a relation from A to B? Okay, now see, from relation from A to B in the ordered pair, the first element must be from A. Clear? So in this ordered pair, F, the first element 1, A, 2 belongs to A, 3 belongs to A, 4 belongs to A, 2 belongs to A, right? And the image, right, that must be belonging to codomain. So yes, 5 belongs to B, 9 belongs to B, 1 belongs to B, 5 belongs to B, and 11 belongs to B, right? So yes, in first case we will say yes, it is a relation from A to B. Clear? Now the second case, f is a function from A to B. So now when can a relation be said from a function, right? So what happens in a function? In a function, every element of domain have one and only one image, right? But what you see here, 2. If I take 2, it is having two image, 9 and 11, right? Here 2 is having two images. Therefore, it is not a function, right? Okay, so there is no constraint for relation, but for function there is a constraint that every element must have one and only one image. Then only you can say it as a function. But here you can see that 2 is having two images, hence it is not a function. Clear? So note down question number 10. Okay, now let's move to the next question, that is question number 11. Question number 11. Let f be the subset of z cross z, means z equal to integers, defined by f. Here it is given f equal to ordered pair AB, A plus B. Okay, and A, B both belongs to Z. Clear? Now see, we have seen earlier that what we can take, if this is X, this will be Fx, right? So I can write it down f of AB, that is equal to A plus B. Now the question is to Z. Okay, so what was the criteria for function? Every element must have only one image, means whatever value of AB, we have only one value of A plus B. Yeah. So now, if you want to prove it is a function, or if you want to prove that it's not a function, then let's try to find out a single example. If you are able to find out a single example that for one value of AB there are two different values of A plus B, means two images, then it will not be a function. So first let's try that. If you are not getting it, then we will try to prove it as a function. Okay. Now say AB is a product, right? So now what I can do, I can take if I take two positive values, multiply, answer will be positive. If I take two negative values and multiply, the answer will be positive, right? So let's take simple, A equal to 5 and B equal to 3. So f of AB will be equal to f of 5 threes are 15. And what is that? A plus B. Here it is A plus B, right? So 5 plus 3. So f of 15 is equal to 8. Right? Now let me take A equal to minus 5 and B equal to minus 3. So now f of AB, what will be it? Minus 5 into minus 3, again 15. F of 15. Now A plus B means minus 5 minus C. So now F of 15 is equal to minus 8. Now see here, 15, 15, right? Same, but there are two different images. Means when I take F of 15, I get two images, plus 8 and minus 8. But what was the criteria of function? It should have only one image, right? So here 15 is having two images, right? Therefore it is not a function. Clear? So write down question number 11. Okay, so now let's move to the next question, that is question number 12, and that is the last question of this exercise as well as this chapter. Question number 12. Okay, here set A is given, set A, that is 9, 10, 11, 12, 13. The function is from A to N. Here N belongs to the class of natural number. Right? F is from A to N. What is Fn? Fn is equal to highest prime factor of N. And you have to find out the range of the function. Okay, you have to find out the range. So now first let's select 9, f of 9. So what are the factors of 9? The factors of 9 are 1, 3 and 9, right? Out of that, prime factors. So how many prime? Only one. So highest will be that only. Clear? So here the answer will be equal to. Next is f of 10. Now what are the factors of 10? The factors of 10, 1, 2, 5, 10. Out of them, which are prime? 2 and 5. And out of them, which is the highest? 5. Right? So our answer will be 5. F of 10 is equal to 5. Yeah. Next, 11. So what are the factors of 11? Only 2, 1 and 11. And prime factor, that is only 11. Next, f of 12. So 12 has 1, 2, 3, 4, 6, 12. These are all the factors of 12. Which are, how many of them are prime? 2 and 3. Right? And which is the highest? 3. Right? So the answer will be 3. This is equal to, and the last f of 13. Clear? Now 13, it has only two factors, 1 and 13, and the prime one is 13. Clear? So these are the highest prime factor of n, where the value of n, as it is from a to n, I can take only these values: 9, 10, 11, 12 and 13. So what we got as a range? So these are all the images, okay, and that is the range. So the range of the function is 3, 5, 11. 3 is repeated, so no need to write it down. 30. 3, 5, 11 and 30. Clear? So that was about question number 12. Okay, so just note it down. Okay, students, so that's it for today. Here we had completed chapter number 2, relations and functions. Right? In our next video lecture, we'll start with the next chapter, that is chapter number 3, that is trigonometric function, which is very important chapter. Okay, so till today, that's it. Thank you.